Hello, this is the part B of our previous video about the solved problems of rotational and circular motion. Problem number 6. What is the moment of inertia of a 100 kg sphere whose radius is 50 cm? Given that the mass of the sphere is given as 100 kg and radius of the sphere is given as 50 cm. Converting the centimeter into meter, divide this 50 by 100, we will get 0.50 meter. Solution. As the moment of inertia I of a solid sphere, is given as I is equal to 2 divided by 5 into mr square. This I is the moment of inertia, m is the mass of the sphere, and r is the radius of the sphere. Putting the values for m and r in this equation and solving, we will get I is equal to 2 divided by 5 into 100. 100 is the mass and 0.50 is the radius. Solving this, we will get moment of inertia I is equal to 10 kg meter square, and this is the answer. Problem number 7. What is the kinetic energy of a 5.0 kg solid ball whose diameter is 15 meters if it rolls across a level surface with a speed of 2 meters per second? So this is a solid ball and it rolled down this surface. The mass of the sphere is given as 5.0 kg. Diameter of the ball is given as 15 meters. Converting this diameter into radius, we will divide the diameter by 2. Radius of the ball is equal to 15 divided by 2 is equal to 7.5 meter. Linear speed of the ball v is given as 2 meters per second. We will determine the total kinetic energy of this ball when it rolls down this surface. The total kinetic energy is equal to the sum of rotational kinetic energy plus linear kinetic energy. As this ball is rolling and as well as it is traveling in this direction, then it have rotational kinetic energy as well as translational kinetic energy. So the total kinetic energy is equal to linear kinetic energy plus rotational kinetic energy. The linear kinetic energy or translational kinetic energy is equal to 1/2 mv square, where the rotational kinetic energy is equal to 1/2 I omega square, where this I is moment of inertia and omega is the angular velocity of the sphere. Putting the values for translational kinetic energy and rotational kinetic energy in this equation, we will get total kinetic energy is equal to 1/2 mv square plus 1/2 I omega square. Now let's first find the moment of inertia I for this ball and omega angular speed of the ball. The moment of inertia I for a solid ball is equal to 2 by 5 mr square, where m is the mass of the ball and r is the radius of the ball. The mass of the ball is given as 5 kg and radius of the ball is given as 0.75 meter. Putting the values for m and r in this equation and solving, we will get moment of inertia I is equal to 112.5 kg meter square. Now let's find the omega, which is the angular speed of the ball. We know that the linear speed is related with angular speed by this formula. V is equal to r omega, where r is the radius, omega is the angular speed, and v is the linear speed. Solving this equation for omega angular speed, we will get omega is equal to v divided by r. Putting the values for linear speed v and radius r, we will get 2 meters per second divided by 7.5 meter. And finally, we will get the angular speed as omega is equal to 0.266 radian per second. Now, putting the values for mass, linear velocity, moment of inertia, and angular velocity or angular speed in equation number 2, we will get kinetic energy is equal to 1/2 m is equal to 5.0 kg V is equal to 2 meter per second whole square plus 1 over 2 into moment of inertia I is equal to 112.5 kilogram meter square into omega is equal to 0.266 radian per second whole square. Solving this equation, we will get 10 joule plus 4 joule, and 10 plus 4 is equal to 14 joule, which is the total kinetic energy of the ball. Problem number 8. A cylinder of 50 cm diameter at the top of an incline 29.4 cm high and 10 meter long is released and rolled down the incline. This is a cylinder, and this cylinder is released from the top of the incline which rolled down this inclined plane. Find its linear and angular speed at the bottom, neglect fractions. Given data. Diameter of the cylinder is given as 50 cm and 50 cm is equal to 0.50 meter. Radius of the cylinder is equal to diameter divided by 2. Diameter is 0.50 dividing by 2, we will get 0.25 meter. This is the radius of the cylinder. Height of the incline is given as 29.4 centimeter. Converting this centimeter into meter, we will get 0.294 meter, and this is the height of the incline. Horizontal length is given as 10 meter. We will determine the linear and angular speed of this ball when it rolls down here. Using law of conservation of energy, we know that the loss in potential energy, here the potential energy is maximum while the kinetic energy is minimum. So the loss in this potential energy will be equal to the gain in kinetic energy, and the gain in kinetic energy is equal to gain in rotational kinetic energy plus gain in linear kinetic energy. Now, potential energy is the energy possessed by a body due to its position and is equal to mgh, where m is the mass of the ball, g is the gravity, and h is the height, equal to the gain rotational kinetic energy plus the gain in linear kinetic energy. And the rotational kinetic energy we know is equal to 1 over 2 I omega square, where I is moment of inertia of the sphere and omega is the angular speed of the sphere plus 1 over 2 mv square. Now moment of inertia for a cylinder is given as I is equal to 1 over 2 mr square. Putting the value for moment of inertia I in this equation, we will get mgh is equal to 1 over 2 into 1 over 2 mr square into omega square plus 1 over 2 mv square. Simplifying this equation and rearranging, we can write it as 1 over 4 m into r omega whole square plus 1 over 2 mv square. Now we know that v linear velocity is equal to r omega. Replacing this r omega with v, we will get 1 over 4 mv square plus 1 over 2 mv square. Taking mv square common from this equation, we will be left with mgh is equal to mv square into 1 over 4 plus 1 over 2. And 1 over 4 plus 1 over 2 is equal to 3 by 4. So mgh is equal to 3 by 4 mv square. Now the potential energy term is equal to 3 by 4 mv square. Now in this equation, this mass m will cancel with this m. And solving this for v, we will get gh is equal to 3 by 4 v square. Now solving for v is equal to whole under root 4 by 3 into gh, where g is the gravity and h is this height of the incline. We know the gravity is equal to 9.8 meter per second square, and h, the height, is given as 0.294 meter. Solving this, we will get the linear velocity v is equal to 1.96 meter per second. Now let's convert this linear velocity into angular velocity. We know that the linear velocity is related with the angular velocity by this equation v is equal to r omega. Solving this for omega, we will get omega is equal to v by r. Now v is the linear speed, which is 1.96 meter per second, and r is the radius of this cylinder. The radius of the cylinder is given as 0.25 meter. Putting the value for v and r and solving, we will get the angular speed as omega is equal to 7.84 radian per second. Now this is the linear speed and this is the angular speed. Now let's solve problem number 9. Statement: show that when a hoop rolls down on an inclined plane, half of kinetic energy is rotational and the other half is translational. This is a hoop. Now the total kinetic energy of this hoop will be equal to the kinetic energy rotational plus the kinetic energy translational when this hoop rolls down. We know that the kinetic energy rotational is equal to 1 over 2 I omega square. And the kinetic energy translational is equal to 1 over 2 mv square. Now this I is moment of inertia and this omega is angular speed. The moment of inertia for hoop is equal to I is equal to mr square. Replacing this I with mr square in this equation, we will get the total kinetic energy is equal to 1 over 2 mr square into omega square plus 1 over 2 mv square. Rearranging this equation, we can write it as kinetic energy is equal to 1 over 2 into r omega whole square plus 1 over 2 mv square. Now r omega is equal to v. V is equal to r omega. Replacing this r omega term with v, we will get kinetic energy total is equal to 1 over 2 mv square, this is rotational, plus 1 over 2 mv square, this is translational. And the total kinetic energy will be equal to mv square. Now the rotational kinetic energy is equal to half of the total kinetic energy. mv square is the total dividing by 1 over 2, we will get half, which is rotational kinetic energy, and the kinetic energy translational also will be equal to 1 over 2 mv square and is half of the total kinetic energy. Now let's solve problem number 10. A disc without slipping rolled down a hill of vertical height 1000 centimeter. If the disk starts from rest at the top of the hill, what is its magnitude of velocity at the bottom? This disk rolled down from this height, we will determine the magnitude of velocity at the bottom of the hill. Now the height of the hill is given as 1000 centimeter, and we know that 1000 centimeter is equal to 10 meter. Now using law of conservation of energy, this problem is similar with one of the previous problem. We know that large in potential energy is equal to gain in kinetic energy rotational plus kinetic energy linear. The potential energy is equal to mgh, which is equal to 1 over 2 I omega square plus 1 over 2 mv square. This I omega square is the rotational kinetic energy and this 1 over 2 mv square is the linear kinetic energy. The moment of inertia for a solid disk is equal to 1 over 2 mr square. Replacing this value for I in this equation, we will get mgh is equal to 1 over 2 into 1 over 2 mr square omega whole square plus 1 over 2 mv square. Now again simplifying this equation, we will finally get mgh is equal to mv square into 1 over 4 plus 1 over 2 is equal to 3 by 4 mv square. Now solving this equation for v, we will get v is equal to under root 4 by 3 into gh. Now putting the value for g, gravity and height in this equation, we will get v is equal to whole under root 4 by 3 into 9.8 meter per second square into 10 meter, which is equal to under root 130.66 is equal to 11.43 meter per second. And the velocity at the bottom of the hill will be equal to 11.43 meter per second. This is the answer. This is it. Thank you for watching and don't forget to subscribe Easy Edu for more videos.